All right, so let's factor this expression. Now, this expression looks pretty complicated because it doesn't quite look like a quadratic. Although it has elements of a quadratic, you see a squared there, you see a constant over here. Okay, we see a variable, but it's kind of weird. So if we look back to other expressions that we've factored, you know, these look pretty standard, right? That looks pretty standard, okay? But we don't quite have that. But we have something that's pretty close to that, actually. So let me just go back here and let me just show you that, hey, we have 2 times a quantity squared minus 11 times a quantity plus a constant, 15. So if we had 2 times a quantity squared minus 11 times a quantity plus 15, then this is actually in the same format as this quadratic. Okay, the only difference is that this x is not just a single x. This x is actually an expression. It's a little bit more expanded. It's not just an x. But you see how it's the same, x plus 3 and x plus 3. So really we do have this. This is actually a quadratic and can be treated as a quadratic. So I have a little note up here that says substitute to get into quadratic form. Okay, well, what are we going to substitute? Guess what? If I had, instead of x here, if I had something like a w, and I like to use w, I don't know why. But if I had a w, that's a quadratic form. So I'm going to do this. I'm going to say let w equal x plus 3. And I'm going to now substitute what this quantity is for a single variable w, so that I rewrite this like this. And you could pick any letter to substitute, but this is the format that I want you to try. Okay. So does everyone see how this is the same format? I just have this expression substituted for a single variable. Good? Now, a lot of students will look at this and they'll say, yeah, you know what? I actually know how to factor this. I don't know how to factor this one up here, but I know how to factor this one. So it makes it easier. It breaks it down a little bit. So what would we do? Well, I would try to, you could do decomposition, or you could try to factor using your intuition, knowing a couple things. That this first term has to be a product of these two terms, right? That's how FOIL works. So because 2 is prime, I'm going to put a 2w there and a 1w over here, because that's most likely what it's going to be, okay? Barring any fractions or weird decimals or roots or something. So it's probably going to be that. These are all integers over here, so let's keep everything integer. Now 15 could be split up 15 and 1, and then what else? What are the other sets? 5 and 3, right? Okay. So now if I did 5 and 3 here, they either both have to be positive or they both have to be negative. And if you're adding to a negative number, most likely both are going to be negative. Okay? Now, if we did a quick FOIL, is this the factored form of this?
No.
Okay, I'm hearing you guys say no right away. Why not? Well, okay, so, okay, thank you for saying that. Listen, -5 and -3 doesn't add to 11. That actually, that rule doesn't hold true in this case because we have this 2.
Because it's -5 and
Okay, it's not, it's because there's this 2 there, you can't just say, oh, these two have to multiply to this one and add to this one, because the 2 messes things up a bit. So watch, what we have to do is we have to do a quick FOIL, and we have to see if -11 gets, is our result. And here's the FOIL. 2 times -3 plus -5 times w. So -6 minus 5. -6 minus 5. Does that get us to -11? It does actually. Yeah, let me just write that out. So 2w times -3 is -6w. And -5 times w is -5w. When you add those up, that gets you -11. So that means that we have factored this correctly. And we've placed the numbers in the right spot. First time. Good job. Now, if you did this, if you said, oh, I'm going to put the 5 there and the 3 there, a quick FOIL would tell you that you've got something messed up because this would be negative 10 minus 3. Negative 10w minus 3w, does that give you negative 11? No, that does not equal negative 11w. So that means you have to try again. And this is sort of, you know, the intuition method or whatever. The decomposition you went over briefly yesterday. Okay, so now that we've got this, I'm not quite done yet because I have, my original question is in terms of x, so I have to resubstitute now. So wherever I see a w, I have to put in x plus 3. So this w becomes x plus 3. This w was multiplied by 2, so this x plus 3 has to be multiplied by 2. And then the second one is like it. Okay. And now we simplify to get our final factored answer. And that's the way that you can use substitution to simplify the process just a bit. So this is going to be 2x plus 6 minus 5. This is going to be x plus 3 minus 3. That's just going to be x. All right? So 6 minus 5 is 1. So this is going to be, I'll put the x first. And then this is going to be 2x plus 1. So that's actually our factored form of this original, I believe.
Okay, can you just get the sense?
Good question, though. So where did the w go? The w got switched back for the x plus 3. You see, the x plus 3 becomes a w because it's just easier for us to process this instead of the original. Then w is like a dummy variable that we just use to substitute. Now that we've got this factored, now we resubstitute x plus 3 back in. And then the x's are back in the problem. Yeah?
Wait, so what?
Oh, sorry, right here.
From the very top, can we like just expand?
Okay, all right, okay, good question. Can we not just expand at the very top? Okay, so this, when you see this, yes, you could expand, okay, but what you're going to get, you might get a very long, complicated expression, and if you gather like terms and simplify everything, you might get another expression that you can factor, but that expression might not be as easy to factor. It could be. And also, when you expand and multiply and then you gather all like terms, there's a couple extra steps where you could make a mistake. So this one kind of avoids all of that multiplication and all of that addition and subtraction. It avoids those two big steps. But probably for some of these you could. But the thing is, in math, we try and learn processes that help us to get to the answer in a little bit more of an efficient way. So this one would be less work. So if you want to do more work, then you can go ahead and expand that. But it might get a little bit tricky when you've got this big, long expansion. You know what I mean? So yes, you probably could. And I haven't done this one by expanding, but it might not be that bad. You would have lots of common terms, and you might get down to, you would get down to 2x squared plus 2x is what it would simplify to. That's what it would get down to this, 2x squared plus 2x. So if you expanded this, you would have all these, and you'd subtract and gather like terms, and it would get to this, and then you could factor this, right? Oh, that's not right either, is it? 2x squared plus x. So then you would factor the x out, and you'd have 2x plus 1, and you would get the same answer. Yeah. But that's not always going to be reasonable, because this x plus 3 could be an x cubed plus 3x minus 2 plus 1. Or something, you know what I mean? Like it could be something really long and like, oh, do I really want to go through that? No, you don't. So this is a good process to learn. But yes, good question. Okay, anybody else? Have a question on that one? Awesome. Okay.